Dark energy. What's all that about? Well, if you've seen another video, you might remember this video about the cosmic scale factor, this graph rather. It starts here, and we're here. Then it could go sort of one of three ways, couldn't it? Go flat, or it could big crunch again. But then, you may remember type 1a supernovae. Remember those are standard candles in that you can, you know exactly how luminous they're supposed to be, so you can work out exactly how far away they are. So, we can observe them very, very far away because they're so, I mean, they're not luminous for supernovae, but they're still supernovae, they're very luminous. And we can observe them at the very edge of the universe, or pretty near the edge of the universe. And the weird thing is, they're going much faster than we would expect. This model assumes there's only two kinds of energy, you may remember, from this formula. Gravitational potential plus kinetic energy. So any particle out there must be slowing down, because the only force acting on it is gravity pulling it back if it's at the edge of the universe. But here's the weird thing. Some of the distant galaxies are accelerating. Type 1a supernovae accelerating. We've known this since the late 90s. You know, I didn't personally, but we have. And the Nobel Prize was given for it to Schmidt, Perlmutter, and someone else, maybe 10-ish years ago. So accelerating galaxies near the edge of the universe. So they just seem to have got extra energy. No explanation really. And I love the humility of science there. We just don't know. We just don't know what's happening there. So for the distant galaxies, this might still apply to relatively close galaxies, but distant galaxies, they're speeding up. Might have heard of the Big Rip, and that's crazy. So they're going faster than we would expect. So there might come a time when it's going too fast to ever communicate with us. The universe is sort of ripped apart. So dark energy, and if you equate energy and mass at the rate of c squared, so if you consider all the mass energy in the universe, then it accounts for something like 2/3 of the mass energy. So about twice as much as all the dark matter and the regular baryonic visible matter that we know about. So it's a different thing from dark matter. Be sure you can write a couple of marks worth on this, and be sure you know if it's how it's different from dark, just change that, from dark matter. That's the thing about the rotating galaxies.